Welcome back to our next session on cloud computing. In this session we will learn about computer paradigms, new computing developments, cloud deployment methods and cloud computing service or delivery model, and risks and challenges. Now let's discuss about the cloud computing paradigms. There are 4 cloud computing paradigms: centralized computing, parallel computing, distributed computing, and cloud computing. Alternatives could be concurrent computing, ubiquitous computing, and internet computing. IoT equals networked collection of everyday objects including computers, sensors, humans, etc. Internet clouds equals the result of moving desktop computing to service-oriented computing using server clusters and huge databases at data centers. Now let's discuss about new computing developments. We will discuss some of the mostly used technologies. There are basically 3 technologies: Web 2.0 services, Internet clouds, and Internet of Things. We will discuss each in details. Let's discuss about Web 2.0. Web 2.0 is the current state of online technology as it compares to the early days of the web, characterized by greater user interactivity and collaboration, more pervasive network connectivity and enhanced communication channels. Web 2.0 refers to World Wide Web websites that emphasize user-generated content, usability, ease of use, even by non-experts, and interoperability. This means that a website can work well with other products, systems, and devices, for end users. The term was popularized by Tim O'Reilly and Dale Doherty at the O'Reilly Media Web 2.0 conference in late 2004, though it was coined by Darcy DiNucci in 1999. Web 2.0 does not refer to an update to any technical specification, but to changes in the way web pages are designed and used. Now let's discuss about Internet clouds. A model for allowing convenient, on-demand access from anywhere to a shared pool of configurable computing resources like networks, servers, storage, applications, and services, that can be rapidly provisioned and released with minimal management effort or service via Internet. Cloud computing is a recent trend in IT that moves computing and data away from desktop and portable PCs into large data centers. Let's understand the concept behind cloud computing. In a traditional physical computing environment, software such as an operating system or enterprise application has direct access to the underlying computer hardware and components including the processor, memory, storage, and so on. As we know, Microsoft Exchange Server is a mail server and calendaring server developed by Microsoft. It runs exclusively on Windows Server operating systems. Here the Exchange Server is dependent on everything below it, so in case your operating system fails or hardware has issues, then it shuts down your Exchange Server and hence mail service of your organization is interrupted. The concept of the cloud computing is that you are trying to separate application, operating system, and the hardware. Now let's focus on Internet of Things (IoT). The Internet of Things, IoT, is the network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuators, and network connectivity which enable these objects to connect and exchange data. Each thing is uniquely identifiable through its embedded computing system but is able to interoperate within the existing Internet infrastructure. See the diagram, it illustrates the IoT completely. Now let's discuss about characteristics of cloud computing. There are 5 characteristics of cloud computing. On-demand self-service: can you get a subscription to this web application without human interference? Broad network access: if you use this application extensively, probably together with a lot of people, then does this web application still work properly? Resource pooling: does it affect me in a negative way if others are using this web application? Rapid elasticity: if I decided to not use this web application with 5 users, but with 5.000 users, does this web application provision the resources to make this happen in a short time? Measured service: can I measure how much resources I use, and do I pay only for resources related to my web application use, as subscription? If 1, 2, 4 and 5 are answered with a yes and 3 with a no, then by the definition of NIST you can call these specific web applications cloud computing. So web applications can be called cloud computing depending on the characteristics. Cloud computing comes in 3 service models: Saas, Paas, IaaS. This variant would be Saas, software as a service. To understand cloud computing, we need look into many other components of cloud computing, like the simplest form of cloud computing is web applications. A web application is a computer program that utilizes web browser like Google Chrome, Mozilla Firefox to perform tasks over the internet. In computing, a web application or web app is a client-server software application in which the client, or user interface, runs in a web browser. Examples of computer applications that use the client-server model are email, network printing, and the World Wide Web. Web applications use a combination of server-side scripts, PHP and ASP, to handle the storage and retrieval of information, and client-side scripts, JavaScript and HTML, to present information to users. These applications allow employees to create documents, share information, collaborate on projects, and work on common documents regardless of location and device. Increased usage of Internet among companies and individuals has led to the widespread adoption of web applications. Web applications give business the ability to streamline their operations, increase efficiency, and reduce costs. Here a user sends a request to the web server over the Internet either through web browser or the application's user interface. Web server forwards the request to the appropriate web application server, which further processes the request and generates the result. Web application server sends results to web server with the requested information, which further responds back to the client with the requested information, and that appears on the user's display. Online apps such as email clients, word processors, spreadsheets, and other programs provide the same functionality as the desktop versions. However, have an added advantage of working across multiple platforms, having a broader reach, and being easily accessible from anywhere. So the concept behind is that if your hardware fails or computer fails, then you can still access to your work. Web applications run on multiple platforms regardless of operating systems. It eliminates the compatibility issues as all users access the same version. They are not installed on the hard drive, thus eliminating space limitations and hence reduce costs for both the business and end user, as there is less support and maintenance required. Now let's see web applications working. User sends a request to the web server over the internet, either through web browser or the application's user interface. Web server forwards the request to the appropriate web application server. Web application server processes the request and generates the results of the requested query. Web application server sends results to web server with the requested information, and web server responds back to the client with the requested information, and that appears on the user's display. Point to be remembered: Jolt is the bridge between application server and the web server, any supported one, that facilitates web communication and is actively monitored for incoming web request. Now let's discuss about cloud computing and web applications. Web applications run on multiple platforms regardless of operating systems or device, as long as the browser is compatible. All users access the same version, eliminating any compatibility issues. They are not installed on the hard drive, thus eliminating space limitations. They reduce software piracy in subscription-based web application, that is SaaS. They reduce costs for both the business and end user, as there is less support and maintenance required by the business and lower requirements for the end user's computer. Now let's start with cloud deployment model. A cloud deployment model represents a specific type of cloud environment, primarily distinguished by ownership, size, and access. There are 4 common cloud deployment models: public clouds, community clouds, private clouds, hybrid clouds, and there are some other deployment models, which will be discussed in brief. You can see the list of deployment models on your screen. Now we will see public cloud deployment model. A public cloud is a publicly accessible cloud environment owned by a third-party cloud provider. The IT resources on public clouds are usually provisioned via the previously described cloud delivery models and are generally offered to cloud consumers at a cost or are commercialized via other avenues, such as advertisement. The cloud provider is responsible for the creation and ongoing maintenance of the public cloud and its IT resources. Many of the scenarios and architectures explored in upcoming chapters involve public clouds and the relationship between the providers and consumers of IT resources via public clouds. See the diagram. The majority of public cloud deployments are generally used for quality assurance testing, or where user demand peaks and falls at certain times of the day, month, or year. Generally, security and compliance requirements is not an issue. Let's move to our next topic: private cloud deployment model. A private cloud is owned by a single organization. Private clouds enable an organization to use cloud computing technology as a means of centralizing access to IT resources by different parts, locations, or departments of the organization. When a private cloud exists as a controlled environment, the problems described in the risks and challenges section do not tend to apply. The use of a private cloud can change how organizational and trust boundaries are defined and applied. The actual administration of a private cloud environment may be carried out by internal or outsourced staff. You can see the diagram that depicts the architecture of private cloud. Private clouds can be expensive with typically modest economies of scale. This is usually not an option for the average small to medium-sized business and is most typically put to use by large enterprises. Private clouds are driven by concerns around security and compliance, and keeping assets within the firewall. Let's understand hybrid cloud deployment model. A hybrid cloud is a cloud environment comprised of two or more different cloud deployment models. For example, a cloud consumer may choose to deploy cloud services processing sensitive data to a private cloud and other, less sensitive cloud services to a public cloud. The result of this combination is a hybrid deployment model. See the image shown. It shows the architecture of hybrid cloud. A cloud is hybrid. If a company uses a public development platform that sends data to a private cloud or a data center-based application. When a company leverages a number of Saas, software as a service, applications and moves data between private or data center resources. And when a business process is designed as a service so that it can connect with environments as though they were a single environment. Now let's discuss about community cloud deployment model. A community cloud is similar to a public cloud except that its access is limited to a specific community of cloud consumers. The community cloud may be jointly owned by the community members or by a third-party cloud provider that provisions a public cloud with limited access. The member cloud consumers of the community typically share the responsibility for defining and evolving the community cloud. See the given figure. Membership in the community does not necessarily guarantee access to or control of all the cloud's IT resources. Parties outside the community are generally not granted access unless allowed by the community. Let's take an example. Several organizations may require a specific application that resides on one set of cloud servers. Instead of giving each organization their own server in the cloud for this app, the hosting company allows multiple customers connect into their environment and logically segment their sessions. The customer, however, is still using the same pieces of hardware as other folks are. However, everyone is hitting these servers with the same purpose to access that one application, which is what makes it a community cloud. This is great for organizations that are driven by compliance and regulatory measures. Government, healthcare, and some regulated private industries are leveraging the added security features within a community cloud environment. Apart from all stated deployment models, there are some other models too. Let's discuss about them. Additional variations of the four base cloud deployment models can exist. Examples include virtual private cloud, also known as a dedicated cloud or hosted cloud. This model results in a self-contained cloud environment hosted and managed by a public cloud provider, and made available to a cloud consumer. See the example on the image shown. Benefits of virtual private cloud. Security. The traffic to and from the virtual private cloud stays within the corporate firewall without crossing the internet. Is ensured through the use of security policies or by encryption, tunneling, private IP addressing or allocating a unique VLAN to each customer. Application performance. In virtual private cloud, the cloud resources are routed through the corporate MPLS-based WAN. Thus, traffic with a high priority can be marked and delivered accordingly. Bandwidth efficiency. Users will take the shortest and most efficient path to the application. Let's see InterCloud deployment model. InterCloud, this model is based on an architecture comprised of 2 or more interconnected clouds. InterCloud is the concept of connected cloud networks, which includes public, private, and hybrid clouds. It incorporates a number of technology efforts put together to improve interoperability and portability among cloud networks to one seamless mass in terms of on-demand operations. Let's discuss about layer structure. 3 layers are as follows. Infrastructure. The resource layer is the infrastructure layer, which is composed of physical and virtualized computing, storage and networking resources. Platform layer is the most complex part, which could be divided into many sublayers, e.g. a computing framework manages the transaction dispatching and / task scheduling. A storage sublayer provides unlimited storage and caching capability. Application or software layer could support large and distributed transactions and management of huge volume of data, based on the underlying resource and components, the application. Now let's discuss cloud computing service model. There are various broad ways a cloud-based service is consumed and utilized. In the world of cloud computing, there are 3 different approaches to cloud-based services. Infrastructure as a service, IaaS. Platform as a service, PaaS, and Software as a service, Saas. We will discuss each models in details. Let's discuss infrastructure as a service, IaaS, model. The capability provided to the consumer is to provision processing, storage, networks, and other fundamental computing resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The consumer does not manage or control the underlying cloud infrastructure but has control over operating systems, storage and deployed applications, and possibly limited control of select networking components, like host firewalls. The service provider owns the infrastructure equipment and is responsible for housing, running, and maintaining it. The customer typically pays on a per-use basis. See the diagram. It shows the complete structure of infrastructure service model. The customer uses their own platform, Windows, Unix, and applications. Now let's see platform as a service, PaaS, model. The capability provided to the consumer is to deploy onto the cloud infrastructure consumer-created or acquired applications created using programming languages, libraries, services, and tools supported by the provider. The consumer does not manage or control the underlying cloud infrastructure including network, servers, operating systems, or storage, but has control over the deployed applications and possibly configuration settings for the application hosting environment. PaaS facilitates deploying applications without the cost and complexity of buying and managing the underlying hardware and software where the applications are hosted. You can refer to the image shown on the screen. The customer uses their own applications. Now let's discuss our last service model, software as a service, SaaS. The capability provided to the consumer is to use the provider's applications running on a cloud infrastructure. The applications are accessible from various client devices through either a thin client interface, such as a web browser, or a program interface. The consumer does not manage or control the underlying cloud infrastructure including network, servers, operating systems, storage, or even individual application capabilities, with the possible exception of limited user-specific application configuration settings. Typically, these services are available to the customer for a fee, pay-as-you-go, or a no-charge model. See the diagram, it shows the complete structure of Saas. The customer accesses the applications over the internet. Now let's discuss about cloud architecture. Many organizations and researchers have defined the architecture for cloud computing. Entire system can be divided into the core stack and the management. In the core stack, there are 3 layers. 1. Infrastructure. 2. Platform and 3. Application or software layer. The resource layer is the infrastructure layer, which is composed of physical and virtualized computing, storage and networking resources. The platform layer is the most complex part, which could be divided into many sublayers, like a computing framework manages the transaction dispatching and or task scheduling. A storage sublayer provides unlimited storage and caching capability. The application server and other components support the same general application logic as before, with either on-demand capability or flexible management, such that no components will be the bottleneck of the whole system. Based on the underlying resource and components, the application could support large and distributed transactions and management of huge volume of data. All the layers provide external service through web service or other open interfaces. Cloud architecture is depicted in figure. Now let's discuss about cloud hosting. An instance is defined as a container of resources sharing technologies with its physical host that are pre-installed for you on a cloud computing platform. You can see the diagram. Now let's discuss about the risks and challenges in using cloud. Cloud computing is a serious risk for the IT professionals using cloud from the public computer system. It should be handled very smartly. Anyone who gets the user credentials can misuse it. There are some challenges as well. Increased security vulnerabilities. Reduced operational governance control. Limited portability between cloud providers. And multi-regional regulatory and legal issues. Hope you liked this session. We will get back with some more interesting topics. Till then, thank you.